adder, subtractor, magnitude comparator. So, review natin adder saka subtractor. Yung multiplexer saka demultiplexer sa another module yun. Adder, subtractor, review tayo. Then yung ngayon is yung magnitude comparators, yung combination. So, ito ay ginagamit to help sa mga large bit, larger bit. Right? So, combinational circuit, tulad ng sinabi ko kanina, is where the output of any time depends only on the present combination of inputs at the point of time with total disregard to the past state of inputs. So, logic gate, siyempre, is the most basic building blocks of combination logic. So, sila ang bumubuo nitong mga to. Kaya natin sila na-tackle, pati, at ito ay pine-perform defined by a set of Boolean expression. Kaya din maraming expression. At saka meron din dito yung Parno map para simplify ang ating expression. So, ito yung generalized combinational circuit na N, combinational logic, tapos magiging N. So, dito sinasabi lang introduction about sa combinational circuit bilang Boolean expression. So, yan. Bibilang naman to. So, ito yung combinational circuit na may normal and complemented inputs. Ayan. So, converter para sa inputs and output. Ito, yung sample natin, yung half adder subtractor. Pakin na natin yan. May ganitong expression para sa y1254 gamit yung A and B inputs natin. So, implementing combinational logic, siyempre, unahin natin para gumawa ng design is yung state by problem and identify mo yung input-output, then yung relationship ng input-output, mo, and construct ka ng truth table, gamit yun. Then, tulad ka ng Boolean expression, tapos i-simplify mo siya. Then, simplify form, yun na yung gagamitin natin. So, simplify siya gamit yung Carnot mapping. So, yung arithmetic circuit, basic building blocks ay nagsisimula sa half adder na nag-a-add ng 2 bits. So, kung nag-a-add siya ng 2 bits, so ang inaano lang niya is 1 bit. So, A and B. Tig-isang bit lang yung half adder. And then yung 4 bits na, yung 2 bits, saka 2 bits na yung pag-a-add natin. So, 4 bits na siya, or minimum ng 3 bits is full adder na. So, sa half adder is yung sum carry yung ating output. Sum is ganyan. Expression and then carry is naka-add block. Okay, so verify ng table, figure, and then ito yung logic implementation niya. XOR, kasi itong expression na yan is XOR. XOR talaga. So, naka-AND siya. So, A and B. So, napansin ko, sa mga nakaraan natin mga practice is nagkakalituhan pa yung iba sa paggamit ng AND saka OR gate kapag i-convert yung Boolean expression sa logic na circuit. So, yung multiplication is AND and yung plus sign is yung OR. Okay? So, dito is XOR. And then, dahil sinabi natin na yung NAND and NOR is an universal gates. Dito yung XOR, pansin nyo, ginawa siyang NAND lang dahil yun yung condition na sinasabi. And then yung AND is naging ganito. So siya is, pwede siyang gawing AND gamit lang yung NAND. So sa full adder, process na ng 3 bits minimum. So, may sum and carry pa rin. So, kaya lang may dito is may carry din na tayo. And output pa rin is sum and carry out. So, dito, sinasabi na yung based on the truth table, nakagawa ng Boolean expression tayo. And then, based dito naman sa simplified na Carnot mapping, ating sum is cannot be simplified na. So, as is na siya. And then, yung carry out na simplify natin. So, ito yung carry out na simplified form ng full adder. So, ito yung kanyang logic diagram. Puro and then or, puro and then or. So, kung i-ano natin yung relationship na half adder sa full adder. So, dalawang half adder plus OR gate is full adder. Okay? So, half and half. And then, ito yung kanyang diagram para sa 4-bit binary adder, pero gumagamit ay ng full adder sa 4-bit na. And then, yung isa naman sa adder is yung subtractor, para hindi siya adder. Kaya lang dito naman ang kanyang output ay tinatawag na difference saka borrow. So, kung mapapansin nyo, yung difference is same lang ng Boolean expression na sum. Then yung borrow is naka-complement lang sa carry. Then, same ng sum. Then yung carry is so yung A is naka-not dito. Okay? So, ito yung kanyang truth table. Then yung kanyang figure. And ito yung kanyang logic diagram. Kaiba nga lang is yung inverter tayo. Punta sa AND gate. So, yung full subtractor naman is yung 3 bits. Okay? Tapos, ito kanyang truth table. Diagram. Simplified ulit yung borrow. And difference, very difference. Simplified forms, agad na siya. So, yung kanyang borrow is naging, okay? So, relationship, yung half adder, saka half subtractor and half yung subtractor is, and then, half, OR gate equals full. Okay? Ito rin yung kanyang, same lang, yung diagram para sa 4-bit subtractor. So, yung control inverter naman is, from the word control inverter, pinakontrol niya yung inverter. Ito yung ginagamit para yung other is maging subtractor. So, makokontrol mo siya gamit yung gate. Gagawin mo 1 or 0, yung nakokontrol mo. Then, input, kapag 1 yung isang gate, inverter siya. Ito ay isang XOR gate. Ginamit yan is XOR gate. Dahil alam natin na XOR is kapag yung inverter is ganitong setup. So, dito na sa other subtractor is, kung makikita nyo, yung 7483 is isa siyang other IC. Then yung 7486 is isang controlled inverter. Ang pinag-connect niya siya, system na to is other subtractor. Other. Okay, ang ng system mo bilang designer. So, BCD other, yung pag-add ng BCD number. So, from 1 to 9, So, makikita natin dito sa ating table. So, ito yung BCD sum. Yung 1 to 9, same sa binary sum natin. Pero kapag dating ng 10, is magkaiba na sila. Kasi dito sa BCD sum, nasa carry na yung 10. Then ulit na naman tayo ng 1 to 9. Basta meron na tayong carry, ibig sabihin siya is lumampas na sa 9. Dito naman from S3 to S0 is parang yun lang ng 1 to 9 ulit. Pero dito sa binary sum, tuloy-tuloy lang. So, as is, 0101, 1010, 0. So, ito ang ginagamit pag sa mga kailangan ng BCD sum. So, ito yung kanyang 3-digit BCD adder. Kailangan nun. So, ito input, output. Then, ito yung input pala. Dalawang input, output, carry, carry in, carry out. Siya ay naka-diagram. Nagagamit ka ng 1, 2, 3, 3 bits. 3 digits, I mean 3 digits adder. Kasi 1 digit is 4 bits. And 1 digit, 4 bits. So, isang digit, isang digit. So, meron tayong sample na sinabi last time. Yan, makikita nyo na lang yan. Naka-upload naman ng ating module. So, continuation is about sa arithmetic logic unit or ALU. So, itong arithmetic logic unit is a digital building blocks capable of performing both arithmetic as well as logic operation. So, ano yung arithmetic? So, arithmetic operations such as addition, subtraction, etc. Then yung logic function naman is yung ANDing, ORing, XORing. Yan. So, siya yung gumagawa nun. So, in two 4-bit numbers as usually available in IC4. Ito, popular tayong IC ginagamit bilang ALU. 74181, 74381, blah, blah, sa TTL, and then 4181 sa Venus family. So, question? Akong the question. Bakit gumawa pa ng TTL na ganyan? And then meron pa tayong CMOS na logic model, ang ALU logic unit. Bakit meron pang ganun? Anong dahilan? Kahit may TTL logic family, na may ganyang model at naglabas din sila ng ganyang model para sa CMOS family. Anyone? Anyone? Sino ang mga kasagot kung bakit naglabas ng TTL family ng ganyang model at ng CMOS din na ganyan namang model? Anyone, guys? Na? Sige, kung lang tatawag. So, Engineer Pangilinan, ano ang iyong masasabi? Bakit merong TTL family na nilabas yung ALU and then CMOS family din, nilabas din? Anong dahilan?
Good afternoon, sir. Sir, sorry po, hindi ko po ako masyado familiar dun po sa ELU po eh.
Hindi, hindi naman yung AL yun, ano ko, I mean, anong idea mo, bakit naglabas pa yung company ng TTL family and then CMOS na logic family na model? Ano ang dahilan nila kung bakit? Sa palagay mo lang ako.
Sir, sa pagkakaintindi ko lang po, siguro po mas ginagamit po yung CMOS po, mas advanced siya or modern compared po dun sa TTL.
Okay, so malapit. Okay. Yun. Isang dahilan yan. Pero may lang ko hinahanap lang akong word. Pero yes, dahil na ako nang nirelease yung PTL, bago yung series. Okay, thank you. Hindi Pangilinan. So, any idea? Sa iba? Ini Jamel? Jamel ba? Jamel? Ampuan?
Good,
Ano ba ako?
good afternoon po, sir.
Captain, no? So, yun, sa question ko, yung
Ah,
idea.
sa tingin ko lang naman is, hindi rin po ako familiar pero siguro po na re-reconfigure po yung quad CMOS. Almost
So,
po
sa palagay mo, CTTL is hindi kayang i-refigure.
or parang
Refigure.
mas advanced po yung CMOS. Yun lang yung pang alam ko po.
Idea mo. Okay.
Opo.
Okay, sige. Thank you. So, at least may idea kayo. So, yung iba, baka alam na yung sagot. Hindi ko lang natatawag. Meron? Wala pa rin? Any idea? Ano yung word na kailangan pa? Isang word lang. Bakit naglabas ng TTL, naglabas din ng CMOS? So, sige, yun lang pa rin. Patawag na lang ako pa. So, Engineer Padilla, idea? Bakit may dalawang family? Engineer Padilla, wala dyan. Engineer Gatchalian, idea?
Guess lang po, sir.
Sige lang.
Mas may advantage po yung CMOS kasi mas mababa po yung power consumption niya.
Alright. Yan, medyo mas malapit na siya doon. So, yun. Pwede dahil sa power consumption niya. Any term doon sa power consumption. Ano yung bakit? So, yun. Ganda yun. Power consumption. Dahil, siyempre, technology nag-i-improve. So, pag naman tayo ng babae, hindi madulid. Madulid. Engineer Miles. Hello. Based sa mga sagot nila na malalapit naman talaga. Ano lang yung isang general term kung bakit naglabas ng CMOS at ng PPL. General term. Si power consumption, specific na yun masyado. So, tama yan. Specific nga lang. General term.
Mas nakaka-save po ng power kapag po snooze yung gamit. Pero kung mas tipid
So,
po
yun
siya
din.
namin,
Okay.
mas
So, about this power consumption. Okay. Oh, tama naman din talaga yun. Tama naman din. Kaya siya naglabas. Pero yung general term lang, masyado kayo ano eh. Easy kayo eh. Masyado advanced eh. General lang tayo. So, ano tayo ba? So, engineer Abu. Tama babasa ko sa iyong surname.
Sir, good afternoon po.
Good afternoon. So,
Sir,
I,
Yes po, sir.
Ano? Yes, idea lang sa
Sir,
masyadong ano na sila,
hindi rin po ako
advanced.
familiar sa ALU at saka po dun sa sinus. Pero po as a guest lang po, siguro po
Okay?
para maiwasan din, para po wala rin pong, para wala pong scarcity ng, ng mga codes.
Scar- Scarcity, mas ano mo, layman's term. Anong ibig sabihin mo?
At paano ba? Para po mas organized, ganun.
Or organized, tapos yung power consumption. Okay, good. Okay? Ano talaga kayo? Masyado kayo specific. Engineer. Ano lang tayo? Chill lang. So, general term lang. Engineer-matic. Janelle, baka may idea ka dyan? Sayang naman yung plus sa performance task na ulitin. Sana Janelle Matic, engineer. Diyan ka ba? Wala. Engineer Fajardo. O dyan? Iya ka ba?
Sir,
Hmm?
para po ano po,
Ah,
makategorize po yung mga ano.
yung mga family.
Opo, sir.
Oh, yun nga eh. Yun nga. Yun yung makakategorize talaga siya. Kaya talaga ano. Pero hindi pa rin yan. Yung exact word. Engineer Fernandez. Engineer Fernandez. Bakit may TTL family na nilabas at Simos family? Diyan ka ba? Wala din. Engineer Jasper Reyes. May idea ka ba? Wala din. Nico. Cabrera na. Idea ka pa, engineer? Wala din. Sir, no idea. Walang mic. Okay. Hindi. Engineer Lloyd. Ano ka bang idea?
Sir, wala po akong idea. Kakasali ko lang din po, sir.
Okay. Sige. Sige. Tuloy ko na lang. Kung wala. So, kaya siya nila nag-release ng TTL at Simos Family para sa compatibility. Okay? Dahil sabi natin is same family, same characteristic na parameters. So, yung power consumption, isa doon. And yun nga, kasi para sa kailangan yung characteristic is same para yung family line. Kailangan yung family same para yung characteristic is okay, compatibility. So, para yung gumawa na ng system na gamit is DTL, meron kayong choice yung gumamit. Mas family. Ayan. So, compatibility. Yun lang naman sana. So, multiplication of binary number is usually implemented in microprocessor and microcomputer by using repeated addition and shift operation. Okay, so repeated addition man siya and shift operation. Tinatawag na multiplication sa binary. So, binary adders are designed to add only two binary numbers at a time. Instead of adding all the partial product at the end, they are added two at a time. Their sum is accumulated in a register na tinatawag na accumulator registers. Okay, nakarinig na ng accumulator register. Doon na pupunta yung ating sa multiplier. And a multiplier bit is 0, that is very partial product is ignored. Kasi all zero line does not affect the final result. So, ito, huwag niyo muna pansinin yung diagram. So, explain ko yung diagram na yan. Para kapag ito sa kanya module is matabasa yun natin dito. Kahit di nyo ako ma-gets. So, the basic hardware arrangement of such a binary multiplier would comprise shift register for multiplicand and multiplier bits. An accumulator register for storing partial products, a binary parallel adder, and clock pulse generator for a time bar operation. So, yung multiplier ay available din siya sa IC form na sa TTL is include 74-61 bilang 2x4 bit multiplier. So, ito ay 4-bit na multiplicand is designated sa B0 to B3. So, 4 yan. And then, 2-bit multiplier designated sa MO2, M3. So, yung most significant bits na P4 saka M2 are used to represent sign. Okay, so sign. So, yung 74-84 saka 74-85 na 4x4 bit multiplier, they can be used together to perform high-speed multiplication of two 4-bit numbers. Yun yung picture na. 74-84, 74-85. Yun yung gawing multiplier ng 4x4. Kasi itong first 4-bit number, second 4-bit number. Kaya niya. Siya ng dalawa. So, the result ng multiplication is often required to be stored in the register. Kung sa accumulator na tinatawag. The size of this register, the accumulator, depends upon the number of bits in the result. Yan, kung ilan yung bits na result, yun yung kanyang laki. So, which most can be equal to the sum of the number of bits in the multiplier and the so, kaya siya ganyan, katumbas 4, 4, 4, 4. So, katumbas siya ng sum ng multiplier and multiplicand. So, 4 by 4 is 8. So, some IC have a inbuilt register. So, meron sariling combinator yung IC. Yung sum lang. Any microprocessor do not have in their ALU the hardware that can perform multiplication or other complex multiplications such as division, determining the square root, trigonometric. So, the operation in this microprocessor are executed through software. So, for example, a multiplication operation may be accomplished by using a software program that has multiplication through repeated execution of addition and shift instruction. Other complex operation mentioned above can also be executed with similar program. So, yun, yung software na yan is ginagawa lang naman talaga niya. Yung multiplication is repeated addition. Although the use of the software reduces the hardware needed in the microprocessor. So, the computation time is generally higher in the case of software executed operation when compared with the use of hardware to perform those. Okay? So, yun yung multiplier, repeated addition, and the shift of operation. So, So, ito naman tayo sa magnitude comparator na nabanggit ko kanina. So, magnitude comparator naman is compare the two given number and determine whether one is equal to, less than, or greater than. So, the form of three binary variables represent condition na A equals B, A greater than B, A less than B. If A and B are the two numbers na pinag-compare. So, yan. So, depending upon the relative magnitude of two numbers, the relevant output change state. If two numbers, let us say, okay? Let us say, 4-bit binary numbers are designated as A3 to A4, A0. Tapos yung ikalawa is B3 to B0. So, siya is 4-bit binary number. Okay? So, yung two number na yon equal if all pairs of significant digits are equal. So, yung A3 sa B3 is equal, A2 sa B2 is equal, all is equal, then sila is equal. So, in order to determine whether A is greater than or less than we inspect the relative magnitude of pairs significant digits starting from the most significant, yung A3 and B3, and comparison is done by successively comparing the next adjacent lower pair of digits. If the digit of pair under examination are equal, the comparison continues until the pair of unequal digits reach. Okay? So, yung equal, masasabi lang na equal kapag lahat ng binary digits ay yung sa 4-bit na yan is equal dapat lahat. Then yung proseso niya na malalaman niya kung equal or not equal is hahanap siya o continuous yung tignan niya hanggang may isang bit na hindi equal. So, doon natin malalaman kung less than or greater than. So, sample. Yung A I is equal to 1. Then yung A is greater than B, siyempre. Then, pag yung B yung 1, so yung B yung greater than. So, ito yun. Yung X, Y, Z represent ng A equals B, yun yung X. So, yung A greater than B, yun yung Y. Then, A greater than B, I less than B, yung Z. Okay? Okay, dito X, Y, Z. So, katumbas itong condition na yan. So, sa formula na to, I mean equation, yung X natin na tinatawag na equal dapat si A and B. Dapat lahat sila is 1. So, ano yung X3, X2, and X0? Ito yun. So, kung yung X3 is A3 and B3 or A3 not and B3 not. Okay? So, yun yung formula dito. So, siya is naka-AND. So, alam naman natin na yung AND is dapat all inputs are 1. So, the output is 1. So, magwa-1 lang siya pag 1 lahat. So, tama yan. Yan yung equal. So, dito naman sa Y natin, yung mas malaki yung A, dapat sa B. Ito yung formula. Okay? So, then ito is Z. Okay? So, ito yung mas explanation nitong equation na to. Lalong gets yung sinasabi ko. So, dito muna tayo sa 7.25. So, yung X3 will be 1 only when both A3 and B3 are equal. So, okay, X3, 1 kapag yung A3 and B3 equal. And then yung X2, X1, X0, dapat 1 din. Para yung etong X na to is mag-1. Okay? Kasi siya is naka-anding. So, kailangan 1 lahat para magkaroon ng 1. Okay? So, kapag yung X equals to 1, so, ibig sabihin, A equals B. Okay? So, ganun din sa sa 7.26 saka 27. So, kapag yung condition na yan is dito sa una sa x, is may hindi nag-1, so ito ng susunod na condition, alamin na kung greater than or less than. So, yun yung trabaho ni magnitude comparator. So, ito yung kanyang ginagawa. So, magnitude comparator ay meron din sa IC4. So, 7485. So, dito sa IC na 7485 ay device ng CMOS family. Meron din naman tayo, 7485 pala is ETL and then yung 4585 is sa CMOS. Ganong dahilan din. Compatibility. So, pero sila ay may same pin connection diagram function table. Yun nga. Yan lang sa compatibility. Pero yung function, diagram, pin connection, same lang. Yung talaga compatibility. Kaya, iba pa ng model. So, the inside themselves determine one bit number or binary or BCD is less than, greater than the second 4-bit number. Okay? So, it can perform comparison of straight binary and straight BCD na 8, 4, 2, 1. This device can be cascaded together. So, pwede cascaded to perform on larger bits number without any help of external bits. So, this is facilitated by 3 additional inputs called cascading or expansion inputs available din sa IC. Hindi mo ito kailangan buuin. Ang sinasabi na dito is pag kayo is pag-tripan nyo maging designer, is at least alam nyo na kung ano yung laman. Pwede nyo sabihin. So, itong IC na to is 74AS885. Binasa mo yan agad, malalaman mo na siya is TTL family dahil 74. Then AS, siya is Advanced Sikansky. So, kapag binasa mo siya dito, sinabi rin naman yan. The device is an 8-bit magnetic comparator belong to Advanced Sikansky. Yan. Can perform high-speed arithmetic logic comparison on two 8-bit binary, two complement numbers, and produce two fully decoded decisions. The output about one number being either greater than or less than the other. More than the one of these devices can also be connected, cascaded arrangement to perform comparison numbers of longer length. Okay? Ito yung ating 4-bit magnitude comparator. Pero ito ay merong IC. Okay? Sabi lang dito na A3B3 na naka-AND, na naka-NOR, converter, na naka-OR. So, DP output ng equal, DP output greater than. Okay? So, ngayon, yan yung dahilan kung bakit kapag nagpo-program tayo sa ating C++, meron kayong compare na if ganyan, if else condition, ganyan, is less than ganyan, and then else ganyan condition. So, magana si magnitude comparator sa ating sample natin. So, itong problem, design a 2-bit magnitude comparator and also write the relevant Boolean expression. Kung yung tanong, kasi sa aking mga tinuro, magigets mo agad. Sample, mag-let ka ng A and B na yung 2-bit, yun yung compare natin, siya ay may 2-bit. So, A1 and A0, so siya is 2 numbers. May 2-bit. So, if X, Y, Z, yung tulad na sinabi ko, is equal, less than, and greater than, that is, X is 1, Y is 0, and then 0 is 0, this 4, A, and A equals B. So, kapag yung Y naman ay 1, A is greater than B. Kapag yung Z yung 1, then B yung greater than. So, the expression of X, Y, Z can be written as ito. Okay? So, ito is naka-base naman dito sa ating formula na to. Dahil siya is 2-bit lang, so x1, a0. Okay? a1, a0. And then dito is, yung y natin is may x1 dito. So, dito rin, is dito naman is kung gaano kahaba. Ayan. Dito is hanggang x3, kung is hanggang x1 lang. And then dito rin is yung z is hanggang x1. So, kapag ito is, yung Bourne expression is ginawa mong logic circuit. So, kung mapapansin mo, yung x1 is is isang XOR, and then XNOR, and XNOR, so ito yun. Ito rin is naka-XNOR, XNOR, X1, saka ito. Okay, so okay na. Then yung Y, kung makikita mo, is ito yung Y. So, Y, connect siya sa A1 and B1. O, tama. A1 and B1. Pero yung B is naka-inverter, may bilog. So, yun yung B naka-inverter. And siya rin is naka-OR. Ayan, plus sign. Naka-OR siya sa A0. Ayan, A0 and B0 na naka-invert yung B. Ayan, may bilog. Pero siya is may X1. So, yung X1 is yung result ng A1, B1. Okay? Kaya siya nagkong-comparator. So, kailangan meron tayong i-compare. Compare natin dun sa unang result. Okay? Then, yung Z natin, ito rin. Ayan, A, naka-not. Ayan, inverter. Then, siya is plus sign, naka-OR. Then, siya is kumulit sa X1 para i-compare. Yung A natin is naka-not. Ayan, bilog. B0. Ulit, naka-and. Kasi siya is period. So, and. May plus sign yung kanyang total. Siya is naka-OR. Yan. Yan yung iba. Yan nagkakamali. Yung pagbuo ng logic circuit. Pag and, ito. Yung ending. Or, so yun yung sa example number 1. Example number 2. So, hardware implement a 3-bit magnitude comparator, having one output that goes high when 3-bit numbers are equal. Okay, use only NAND gates. So, kung iisipin, siya is may 3-bit na number na merong dalawang number. Dalawang number, 3-bit sila. 3-bit sila. Mag-highland daw kapag sila ay equal. So, okay. So, ang kailangan natin is equal. Hindi natin kailangan na less than and greater than. So, pero ang sabi dito is NAND gates only. Okay. So, yung equivalent condition of two 3-bit numbers is given the equation na tama. X equals to X2 hanggang X0. So, yun yung formula ng equal. So, ito yun. X2, X1, 0. So, lahat yan is naka-X nor. Yes. So, X nor. Okay? Pero, siya is naka-NAND gates only. So, kung iisipin nyo, yung ating XOR is ito. Ito yun. XOR. Okay? Ganyan ating XOR na NAND gates only. XOR ulit. XOR. And ito na. Puro NAND lang. So, kung gagawin mo lang itong mga to, ayan. So, the equal. Ayan. XOR, XOR. Okay. XOR, XOR. Okay. XOR, XOR yan. Hanggang dito, XOR yan. Hanggang dyan. And then, AND. Diba? Sabi NAND gates lang. So, NAND gates dito. So, kaya nag-convert pa ng isa pa ritong NAND gates bilang inverter para yung dito na NAND gates sa sagot is ma-convert pa niya kasi ang kailangan natin AND. So, yung AND is itong system na to. XOR to, or to, XOR to. So, X is yung A equals. Sana na-gets nyo yung diagram yan. So, ito na yung ating summary. Yung combination of circuit is where the output time depends only on the expression. Okay. Logic gate is the most building blocks of combination of logic. And logic function performed by combination circuit is fully defined by a Boolean expression. Then, ito yung mga steps para mag-design statement of the problem, identification of the input-output, write the Boolean expression, and minimization, implementation of minimized Boolean expression, and yung basic building blocks that form the basis of all hardware used to perform arithmetic operation of binary numbers, half adder, full adder, half or control inverter, and then ito nga ating multiplier and magnitude. Sa live application natin, we already know that there are steps involved in design of a logic circuit. Like making decision in life, there are guides to help us make a good guides to help us make a good. So, any question, guys?